Hello physics students, this is Mrs. Buchanan and this is flipped video number 2. We are going to review real quickly our big idea. Remember that we are talking about Newton's first law of motion, or his law of inertia, and the big idea is forces cause changes in motion. So if we skip to our next learning objective, it's describe Galileo's idea about when a force is needed to keep an object moving. So let's talk a little bit about the Greeks again, going back a little bit to Aristotle. Have you ever seen the planet Mars? Mars is among the brightest planets in the night sky. Ancient people were keen observers of celestial objects in order to define the time of year and the direction of travel on Earth. These observers noticed that 5 bright wanderers or planets generally followed an eastern course through the constellations. Yet, unlike the stars, they also moved westward for periods of time. The deep red color of one of those planets caused the Babylonians to associate it with disaster, and the Romans to name it after their god of war, Mars. Early records of the motion of Mars helped develop the concepts of the solar system centuries before the invention of the telescope. So are stars and planets like Earth? About 2,500 years ago, Greek philosophers tried to determine what the world was made of by making observations of everyday occurrences. Some of these scholars believe that all matter on or near Earth was made up of 4 elements: earth, water, air, and fire. Each element was thought to have a natural place based on its heaviness. The highest place belonged to fire, the next air, then water, and at the bottom earth. Motion was thought to occur because an element traveled in a straight line toward its own natural place. So if you go back and think about Aristotle, that was what he believed. He believed in natural motion. Ancient people observed that the sun, moon, stars, and planets such as Mars did not behave this way. As far as anyone could see, these celestial bodies were perfect spheres and moved in circles about Earth forever. So here's your geocentric their theory. They certainly didn't obey the same laws of motion as objects on Earth, so it seemed that they couldn't be made up of the 4 elements. Rather, they were formed of the 5th element, quintessence. The writings of these early Greeks, lost to Europe for hundreds of years, were studied and translated by Arabic scholars. In the 12th century, the writings made their way to Europe and were accepted as truth that did not have to be questioned or tested. So this was hundreds of years now. One of the first European scientists who claimed publicly that the ancient books were no substitute for observations and experiments was Galileo Galilei. Now, Galileo was born in Pisa, Italy, in the same year of William Shakespeare was born and Michelangelo died. He studied medicine at the University of Pisa and then changed his studies to mathematics. He developed an early interest in motion and was soon at odds with others around him who held the Aristotelian ideas on falling objects. So again, he went against Aristotle. He left Pisa to teach at the University of Padua and became an advocate of the new theory of the solar system advanced by Copernicus, our heliocentric model. Galileo was one of the first to build a telescope, and he was the first to direct it to the nighttime sky. He discovered mountains on the moon and the moons of Jupiter. And he actually was able to estimate the heights of the mountains on the moon by estimating the lengths of the shadows. He published his findings in Italian instead of Latin, the standard scholarly language of his time, and because of the recent invention of the printing press, his ideas reached many people. He soon encountered disagreements with the Roman Catholic Church, just like Copernicus, because remember, the Church accepted the ideas of Aristotle, and he was warned not to teach and not to adhere to the Copernican views. He restrained himself publicly for nearly 15 years, thinking he had found a way to present the Copernican views without contradicting church doctrine. Galileo published his observations and conclusions. However, he was brought to trial and was found guilty, and he was forced to renounce his discoveries. So in other words, he was forced to keep his mouth shut and say that he was wrong. Nevertheless, he was sentenced to house arrest for the remainder of his life. He was broken in health and in spirit. He completed his studies on motion, and his writings were smuggled from Italy and were later published in Holland. Galileo, though, had damaged his eyes earlier by looking at the sun through a telescope, which led to blindness at the age of 74, and he died 4 years later. So, he is the father of experimental science. We talked earlier about him as being the father of the scientific method, and again, he was a follower of Copernicus' theory of heliocentrism. Now, Galileo strongly believed that force wasn't necessary to keep an object moving, that what caused an object to stop moving was a force. And he said that that force is friction. So he performed many experiments. He believed that experiments were so much more important and observations were so much more important than reading somebody else's work in a book. And that's basically what his premise was that I'm going to go out and do these experiments. So he actually concluded that horizontal motion is eternal. It never, ever stops. If you roll a ball along the floor, it would go on forever, according to Galileo, until something else acts upon it. Okay? So only when friction is present is when a force is needed to keep an object moving. So if you have friction, you're going to have some sort of force that's going to keep that object moving. So what is friction? Friction is a force which acts between materials as they move past each other. For example, if I was moving a big piece of furniture, I would rather move it on a smooth floor like a laminate or a wood floor or a tile floor than say shag carpeting, because that shag carpeting is going to create that friction. Or if I had to move something across a rubber mat, I would rather move it on a smooth surface versus a rubber mat that would cause a tremendous amount of friction. Now, we think a lot about friction when we talk about traction and we talk about cars. And think about the lack of friction. Say in a couple months from now we have an ice storm that comes in. You're not going to have a whole lot of friction that's going to keep your car on the road. So, friction is caused by irregularities in the surface of objects that are touching. No object is absolutely smooth. And any type of irregularity, any kind of gaps or dips or little things that stick up, that would cause friction. In an ideal world, there would be no friction or drag force. And we'll talk more about drag force when we talk about automobiles, particularly when we talk about airplanes. So one of the things that sets Galileo apart is he was very concerned with how things move rather than why they move. And this is huge, so you need to star and circle this. It's concerned with how things move rather than why. And all the previous philosophers, scientists, always were worried about why. This is a how. So he argued that only when friction is present is a force needed to keep an object moving. So here's what he did. The guy took a bunch of balls and he rolled them along plane surfaces with no friction. All kinds of different angles. So he tilted these ramps at angles. So he concluded that a ball rolling down an inclined plane speeds up. Well, duh, we know that. If we roll a ball down a plane, it's going to speed up. Well, his theory states that when it's rolling in the direction of the pull, okay, then it will speed up. And that pull is gravity. So the gravity is forcing it downward. Think what gravity does. Gravity pulls something downward. A ball rolling up an inclined plane slows down because it's rolling in the direction opposed to gravity or opposite of gravity. It's an opposing force. So a ball rolling on a smooth level surface doesn't roll with or against gravity. So would it keep moving? Yes, constant velocity, and if there's no friction, it would move horizontally forever. As long as it doesn't run into anything or gravity doesn't act upon it, it's just going to roll forever at a constant velocity. Now, what is velocity? Velocity is speed and direction. Speed and direction. So in order to continue to keep that ball moving, then he said that there's no push or pull that's required. So he was rolling balls on two facing inclined planes. And what he did is he had the ball rolling down one plane and it would roll up the other plane. So it was kind of like a bowl, so to speak. So he's going down one and then the ball is going up the other. So it's going with gravity and then against gravity. So what he found out was that it would roll to the same height. So if you dropped it, say for example, an inch below the top of the plane, it would roll down and roll back up an inch away from the top of the second ramp. So the smoother the planes, then more equal were the initial and the final heights. So your initial height is your starting height, your final height is your ending height when it comes up on that other plane. The same initial and final heights were achieved when the second incline is at a smaller angle than the first. Even though the ball traveled more distance, it still reached the same height. When the second incline is moved to perfectly horizontal, the ball continues and is only stopped by friction. So, the tendency of a moving object to keep moving is natural. So he did agree with the natural part of it. Every object, every material object resists change to its motion. That's inertia. Circle this. The property of a body to resist changes to its state of motion is inertia. We're going to do two labs this week, and both of these will deal with inertia. We're also going to do a mini lab. So we're going to do a mini lab and two labs, and that'll help you with this concept of inertia. So Galileo published his results. He was obviously tried and arrested. He supported Copernicus's heliocentric theory. The Catholic Church banned him or condemned him to house arrest because he contradicted church doctrine. And again, they smuggled his writings from Italy to Holland. His findings about motion and inertia did two things. The first thing is it discredited Aristotle's theory on motion. So now people figured out Aristotle was wrong. The second thing it did, and this to me is the most important, is that it opened the door for Isaac Newton's laws on motion. So this sets the stage that now Isaac Newton had everything that he needed based on all of Galileo's experiments. Isaac Newton did repeat them, and by repeating them he received the same, he had the same results. So with that being said, that confirms that it's true, unless someone else finds it incorrect. But this gave Isaac Newton a lot of clout, because later Galileo ended up being someone that everyone respected once he passed away, unfortunately. Alrighty, this finishes our video number 2, our 3-3 Galileo on motion. Make sure that you have taken the notes on these slides, and now you have accompanying questions that you are required to complete. I'll see you later.